The expression limit as h approaches 0 of the square root of h plus 4 minus 2 divided by h represents the derivative of a function f at some number a. Identify f and a. You're going to want to write down the limit definition of the derivative, and we're going to want to use the one that involves h approaching 0. And rather than memorizing it, think about where that expression comes from. Suppose we have some function here, and this is not the function in the problem. This is just some other function. And we're going to look at two different points. Suppose I have a point here, and I'll call that point with a x-coordinate of a. And then I have another point that's, looks like it's maybe about here, and that's going to be a plus h. In other words, it's a distance h along the x-axis here. And if this is a, then the y-coordinate is f of a. And if this is a plus h, then the y-coordinate is f of a plus h. Okay, so what we're really trying to do is to look at the slope of the line connecting these 2 points. Well, I can write that. That's change in y over change in x, so that would be f of a plus h minus f of a all over a plus h minus a, but a plus h minus a, that's just h. And that's the secant line. I want the slope of the tangent line at A, which means I'm going to let this point get closer and closer and closer and closer and closer to that point, which is essentially the same thing as letting h here shrink to 0, because if h shrinks to 0, then this a plus h gets closer and closer to a. In other words, I'm going to take the limit as h approaches 0. And that is the limit definition of the derivative at point A. Okay, so now we have this expression. We have the limit as h approaches 0 of the square root of h plus 4 minus 2 all over h. And we have to figure out what f and a are. Well, I see a square root here, so maybe we could try letting f of x be the square root of x. How about that? Because we know that this part is what's corresponding to this part, f of a plus h. Well, let's see here, f of a plus h. So that maybe means that the a is the 4. We can try it out. Remember, just try it out. If it doesn't work, you pick something else, but it seems likely. Let's try it. Okay. So I'm going to try rewriting it now without looking at the original expression. I'm going to use the definition and see if I get the same thing. So this would be the limit as h approaches 0 of, and we have f of a plus h. So that's going to be the square root of, and then instead of x, I'm going to have a plus h. But what's a? A is 4. So that's 4 plus h. 4 plus h. Okay, so 4 plus h minus, now I have f of a. A is 4, square root of 4. That's what's going to go there. All over h. And look, I think this is the same thing, because this is the limit as h approaches 0 of the square root of, well, 4 plus h, that's the same thing as h plus 4. And the square root of 4, that's 2. All over h. Same thing. So this is actually the limit definition of the derivative at 4.